We're going to start on page 22. This is Algebra 1, case 1104. We're going to start on page 22. We're going to go to 26. Okay, so we'll do a new section, and then it's going to go into the checkup, and I'll go over a little bit in the checkup, okay? So the first thing that we're going to talk about is page 23. So I just wrote down 2 examples right here just to kind of show you the difference and how to simplify these, okay? So what you're doing now is you're going to rationalize the denominator. So we don't want the denominator to be a square root or a cubed root or a fourth root. We don't want that. We want to get rid of that. You can multiply both the numerator and the denominator by the same thing without changing its value. So both the top and the bottom by the same, and it will not change the value of the problem. So here on this first one, we have the square root of 7 over the square root of 2. Well, I want to get rid of this square root of 2, and how do I do that? I'm going to multiply both the top and the bottom by the first number that I get to that will be multiplied by 2 and make it a perfect square. So in this case, it's 2. Okay? So I'm multiplying both the top and the bottom by 2. So 7 times 2 is 14, so that is the square root of 14 over 2 times 2 is 4, which is the square root of 4. Okay? So that leaves me with the square root of 14 over 2. This 14, it can't be simplified any more than what it already is. It is 14. The only factors of 14 are 1 and 14 and 2 and 7. There are no other factors of 14, so that's as much as it can go. So that's your final answer for this problem. Okay, but down here on this other one where you have 9 over 8, well, 9 over 8, the common factor here, or if you were to just multiply it by the 8, it's going to give you a big number. And we don't want that. We want to find the lowest one, the lowest factor that you can get before to end up with a perfect square. Well, for starters, 9 is a perfect square. So let's get rid of it. It's 3 over the square root of 8. So now what are we going to multiply both the top and the bottom by? We're going to multiply by the square root of 2. Notice we're not multiplying by 2. We're multiplying by the square root of 2. There is a difference. All right, so we're going to do 8 times 2, which is 16, over, or that's all under 3 times the square root of 2. So what's the square root of 16? 4. So 3 times the square root of 2 over 4. And can this go anywhere else? No, it cannot. So that is your final answer. All right, so let's jump on down there to the problems, okay? So number 1. Probably shouldn't do number 1 because you should be able to do it on your own. You should be able to do several of these on your own, but we'll start here. So I'm not going to break it down like I did these up here, like I did that one. I'm just going to start here. So what is the smallest number that I can multiply by 3 that's going to give me a perfect square? Well, the answer is 3. So I'm going to multiply both the top and the bottom by 3. So 2 times 3 is 6. And 3 times 3 is 9. The square root of 9 is 3. And can we go anywhere else with that? So that is your final answer. All right. So let's skip down to number 9. Let's let you do number 3, the 2 over 9. You can do number 2 on your own. It's very similar to number 1. So we're working with the cubed root here. Okay. So now we want to know what number we can get to that is a perfect cube of whatever. So I'm looking at the denominator. I don't care about the numerator. I'm looking at the denominator. That's what I want to get rid of. So what can I get to from 9 that is a cubed root? So what are our cubes? 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Okay, well, I got to that because 3 times 3 is 9. 9 times 3 is 27. So let's multiply the top and the bottom by 3. Gives me the cube root. Oh, my word. I don't know what's happening. Sorry about that. Oh, and I multiplied by the cubed root of 3. All right, so I have the cubed root of 6 over the cubed root of 27. All right, so there is no cubed root of 6, and there's no way to break that down anymore, but the cubed root of 27 is 3. Final answer. All right, so y'all should be able to do 4, 5, and 6 on your own. 4 is the other cubed root that's there. And just figure out what you can multiply by 25 to give you a perfect cube. And you need to think about your cubes. We already know that 2 is 8, 3 is 27. So what is 4? 4 is 64, I'm pretty sure. And what is 5? And just go on from there, okay? Once you find out what cubes you have what your perfect cubes are, then you should be able to decide what to multiply that 25 by. Okay, so let's flip over to the top of page 24. Let's do number 7. So we have 2a to the third, nope, that's a 2. 2a to the second over 3 times the square root of 3a. Okay? So remember, my plan is to get rid of this denominator square root here, okay? I want to get rid of that. All right, so I'm going to multiply both the top and the bottom by 3a. Why am I going to do 3a? Because what can I get to? What perfect square can I get to with 3? The closest one is 9. That's 3 times 3. And then with a, I need it to be a square, right? I need it to be an even number, 2, 4, 6, 8. Well, the first one is 2. So now I'm going to multiply the numerator. It's going to give me 2a squared times the square root of 3a over 3 times the square root of 9 times a squared. It's going to break down to this square root becomes 3a. The square root of 9 is 3. The square root of a squared is a. 3 times 3 is 9. And then my a. Oops, I left my a square off right here. Okay, so now am I done? The answer is no, because I can cancel. It's going to leave me with 2a times the square root of 3a over 9. This is your final product. Okay, so number 8 is very similar to number 7. You should be able to do it. I'll do kind of torn between doing number 9 and number 10. I'm going to do number 10. I'm going to let y'all do number 9 because it's 1 over 4. And what is the square root of 1? It's 1. So the cubed root of 1 is 1. So you should be able to figure out number 9. All right, so let's do number 10. Not that you can't figure out number 10. Just want to make sure that you understand it. Number 10 is kind of hard. Okay, so now we have to find the perfect fourth. I forgot I'm not going to rewrite it. All right, so we need to find out what the perfect fourth is. Perfect fourth. Okay, 2 to the 4th is what? 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? And then we have 3 to the 4th is 81. Well, what times 9 gives you 81? If you have one of the calculators that will do it for you, you can just plug this in and it will give you the answer. You just have to make sure you put the 4th root and not square or cubed. But as you can see, it's also easy to do it by hand. All right. So 2 is the 4th root of 16. So this is going to end up being 2 and then multiplied by the 4th root of 9 over the 4th root of 81, which is then going to be 2 times the 4th root of 9 over the 4th root of 81 is 3. Final answer. Okay. Hope that makes sense. Hope it's not too difficult to understand. Hope I'm not going too fast. I don't feel like I am, but I am guilty of moving along a little too quick. All right, so let's move on to the checkup. Okay, we'll do 1 or 2 more of those same problems that will kind of help maybe you to pick it up a little bit better. But once the video is over, don't stop doing math. Finish these problems so that you understand it. All right, so checkup, page 24. We're not going to go over all of these. We're just going to go over a handful of them. And we're going to go quick, okay? Because this is something that we've already been over, something that you should already understand. And in this is those problems that I didn't go over in the videos. I think I stopped the last video at the last checkup. So this will also cover everything that you do from page 8 to page 24. Oh, no, it doesn't. I'm sorry. Page 18 to page 24. Felt like that was a lot. Okay, so starting on page 24, number 1. Okay, so you have 40, x to the 5th, y to the 7th. All right, so how do I find out what my factors are? How am I going to simplify this? Okay, so what are my factors of 40? I have 8 and 5. Neither one of them are perfect squares. I have 4 and 10. Well, 4 is a perfect square. Factors of 10 are 5 and 2, and neither one of them are perfect squares, so this is the one I'm going to be working with. Okay, so I'm just going to break it all down under the radical here so that y'all can see it a little bit better. Okay, so here I have x to the 5th power. how do I simplify x to the 5th power? This is squared, so 5 divided by 2 is what? 4 with 1 left over. Okay, so x to the 4th with 1 left over. Okay, so do the same thing with the 7. 7 divided by 2 is, sorry, not 6, 3. Yeah, 3 with 1 left over. Okay, so 2 times 3 is 6, so y to the 6th with 1 left over. Okay, I think I said that wrong on the x one, but 2 times 2 is 4, so that's how you get that. All right, so there are no factors of 10, so 10 is going to stay inside my square root, or there's no perfect square of 10, so it's going to stay inside there. All right, so that one is done. So I have a 4, it's a perfect square, and it's 2, so I'm done with that. I have x to the 4th. What is the square root of x to the 4th? 4 divided by 2 is what? 2. Leaves me with 1 left over. And then I have y to the 6th. 6 divided by 2 is 3. Done with that. And all I have left is a y. And that is your answer. 2x squared y to the 3rd times the square root of 10xy. Okay, so let's go down. We'll do number 4. You have 7 times the square root of 99. All right, so what are the factors of 99? 1 and 99, 11 and 9. I'm sure there's 3 and 33. But the perfect square is 11 and 9. Okay. Square root of 9 is 3, which leaves me with 21 times the square root of 11. All right, so this is a checkup. This is stuff that you should already know. All right, so number 5. Remember, we want to get rid of the radical in the denominator. So you're going to do whatever you can to get rid of your radical in the denominator. So number 5 is pretty simple. You have the square root of 18 over the square root of 25. What is the square root of 25? It's 5. All right. What are factors of 18? 1 and 18, 9 and 2. So 9 is a perfect square. The square root of 9 is 3 times the square root of 2. All right. So I'm going to skip number 6. You should be able to do that one. Remember, that's a cubed. You should be able to do number 7. It's the 4th root. I did go over what the 4th roots were right here. You can just keep them on going. Okay, number 8, you should be able to do. Well, I'll do number 11 over on page 25. All right. It is the 4th root of 12 over 81. All right, so what is the 4th root of 81? 3. We did that a little bit earlier. And is there a 4th root of 12? Or are there factors of 12 that there's a 4th root of? The answer to that is no. So it just remains 12. That is your final answer. So some of you are probably feeling a little panicked over this stuff. But it's not that difficult. If you just relax, take a breath. You know math. You've gotten this far in algebra. You may have struggled your way through it, but this is some stuff that we've already done. You should have done this in pre-algebra as well. So it's really just bringing back to your memory what we have been doing. Okay, so now let's start combining our radicals. So number 14 is very basic. Your radicals are already the same. Everything is the same. Your radical is the same. Your index is the same. Okay. You might have a little bit of trouble with number 17, but remember, all you have to do is find your common denominator before you start adding and subtracting. Again, if you have a calculator, you can put it in there. But doing it by hand, learning how to do the math by hand is going to help you a lot more in the future. Not all jobs are going to do math constantly, but I'm a nurse as well as teaching at the school, and I use math all the time when I do go work at the hospital. So, and you wouldn't think that nursing would be something that you use math, but knowing these numbers off the top of my head are very important. Okay, so let's go to number 18. Number 18 is one that you have to simplify or that you have to break down. So factors of 18, where I get a perfect square, are 9 and 2. And then factors of 50 that give me a perfect square is 25 and 2. So this is going to end up being 3 times 3 times the square root of 2. Where did I get that 3 from? Square root of 9. And then I'm going to have 2 times 5 times the square root of 2. Where did I get that 5 from? Square root of 25. So I'm going to plug these back into the place that they're supposed to be. So 3 times 3 is 9 times the square root of 2 minus 2 times 5 is 10 times the square root of 2. Now I have the same radical. I have the same index. So I can add these together. So 9 minus 10 Okay, so let's move on. Let me look over here at page 26 real quick. Okay, yeah, I'll do number 21. Should be able to do 19 and 20. I'll do number 21, and then we'll go over to page 26, and we'll do one of those. Okay, so number 21, I have the cubed root of 54 plus the cubed root of 128 plus the cubed root of 250. Okay? So now factors of 54 that are going to give me a perfect cube. If you said 27 and 2, you're super smart. Oh, and then I wrote a 4. Which is going to give me 3 times the cubed root of 2. All right, so since that used a 2, pretty sure that this 128 is also going to use a 2. So 128 divided by 2 is 64, which is going to give me 4 times the cube root of 2. And then 250. So 250 divided by 2 is 125. And then the cube root of 125 is 5. So why did I know to divide all of those by 2? Because when my first one came out to have a leftover of square root of 2, I knew that the rest of them needed that as well. All right, so all of these were addition. So I'm going to add all of this together. 3 times the cube root of 2 plus 4 times the cube root of 2 plus 5 times the cube root of 2. Okay, or you could have just 3 times 4 times 5 instead of writing it out like this. Okay, so 3 times 4 is 7. 7 plus 5 is 12 times the cube root of 2. All right, so go over to page 26, and these are the ones that we just did where we're trying to get rid of that radical in the denominator. We don't really care about the numerator, we just care about the denominator. So 22 you should be able to do on your own. We'll do number 23. All right, so what perfect square was the first perfect square that I'm going to get to when I'm dealing with the 6? So you can go through all the numbers. 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. That 36 is the first perfect square I get to. So 6 times 6, both the numerator and the denominator. I'm going to have square root of 30 over square root of 36, which is going to end up giving me square root of 30 over 6. So does 30 break down any for me to have a perfect square? Well, my perfect squares are 4, and 4 doesn't go into 30, or 16, and that doesn't go into 30. So the next number is 25. That's not going to be it either. So this is my final answer. All right. So number 24, I'll do it, but make sure that you understand what you're doing and you're not just writing this answer down, because you will see another one that is similar to this on the test. So make sure that you understand this. Okay, so I have the square root of 2ab squared over c squared d. All right, so I need to make the denominator a perfect square. And how am I going to do that? I'm going to multiply both the top and the bottom by the square root of d, because I already have c squared, so I'm done with that. All right, so now I'm going to simplify this. I have a b square here. The square root of b squared is b, so I'm going to go ahead and bring that b out, and that gets rid of that. There's no square root of 2, there's no square root of a. 2ad all over cd. Okay, do you see why it is cd? I just didn't write it out, but c squared d times d equals c squared d squared. And the square root of that is cd. All right, so that is your final answer. Okay, so you should be able to do the rest of that on your own. This video is 30 minutes, so hopefully you don't get bored with it. But doing the checkup, there's a lot in that to kind of break down for you. If you have any questions, just kind of rewind and go back over it again.